Morning to one and all. My name is Dherandar Reddy. My registration number is 506. Now in this video, I am going to explain about rotate instructions. Now before we start to learn rotate instructions, first let us see what are shift instructions. So shift instructions. Shift instructions are used to perform shift operations. So these are basically divided into two types. What are they? They are logically shift instructions, and the second type is arithmetic shift instructions. Now let us know about each of them. First, logical shift instructions. So logical shift instructions are classified into two types again. They are logical left shift and logical right shift. So let us see what is a logical left shift. So in this, the leftmost bit is removed and all bits are shifted towards left. So a vacant position is created at rightmost side. So the vacant position is replaced by 0. So in this logical left shift, we have taken one data, and in this we shift the data towards left side. So the bit which is in the leftmost side will be eliminated and a vacancy is created at the rightmost bit and it is replaced by 0. Now let us see with an example to understand that clearly. Now I have taken here 10 10 11 as an example. Now I am performing left shift on it. So after performing left shift, we will have a table like this, and in this here 1 will be eliminated. So starting with 0, then 1, then 0, then 1, then 1, and here a vacant box is created. So here this vacant box is filled by 0. So we can see here this is the newly added bit. Here the leftmost bit is eliminated. So this is the logical left shift. Now let us see what is a logical right shift. Now, logical right shift. In this, the rightmost bit is removed and all the bits are shifted towards right. A vacant position is created at left. It is replaced by 0. So similarly as we have done in logical left shift, in logical left shift the data is shifted towards left side, but in logical right shift the data is shifted towards the right side. So let us see this with an example. Now I have taken the data here. Let us consider this as a data 10 10 110. Now we are performing right shift on that data. So by performing right shift, this 0 will be eliminated and all the bits are shifted towards left. So after that we get the data as this one. So here all the bits are shifted towards the right side and a vacancy is created at the leftmost bit. So in this logical right shift, this vacancy which is created at the rightmost bit is replaced by 0. So as we are learning about rotate instructions, so logical shift instructions are sufficient. There will be no need to learn about arithmetic logical instructions. So now let us start about rotate instructions. Now rotate instructions. These instructions are classified into 4 types. So basically why are we using rotate instructions means in shift instructions, as we have seen, in any shift, for example in logical left shift, the leftmost bit is eliminated, so then the data is wasting, and in logical right shift the rightmost bit is being eliminated, so the rightmost bit data is wasting. So in order to prevent data from wasting, we are using rotate instructions. Now let us start rotate instructions. So rotate instructions are classified into four types. In logical shift operations, we are using the data. To overcome and preserve the lost data, we are using rotation instructions. As I have explained earlier, we are using rotate instructions to overcome the disadvantage in logical shift operations. So the four types in the rotate instructions are rotate left without carry, rotate left with carry, rotate right without carry, and rotate right with carry. So now let us see each of them. First, rotate left without carry. In this, the notation we use is rotate L, which means rotate left without carry. So here we have taken an example, rotate L as to R0. So the data in the register R0 is this one, and in this register we are shifting the data bits 2 bits towards the left side. So this is the meaning of this notation. Now let us see what happens when we shifted this. So before first shift, so by default the data in the R0 is this one, and after performing, as we have to perform 2 shifts towards left side, so first let us perform the first shift. So after performing the first shift, this 0 will be shifted towards left. That means this 0 is shifted towards left, and all the data in this are also shifted towards left. So after first shift, this one is obtained, and the vacancy is created here, and the vacancy is filled with the bit we are using here. So as we are shifting 0, this 0 is used in this. Now wait, I will explain with a clear one. So this 0 is being shifted here, and all the bits are moved towards left side. So 1 0 1, so on 0 1 1, and here a vacant position is created. So as we are moving 0, this 0 will be placed in this vacant position. So this is what meant by rotate without left. So now let us see the second shift also. So now we are performing second shift. Now this leftmost bit is shifted. Now all the remaining bits are shifted towards left side, and a vacancy is created here, and this vacancy is replaced by this number. So after performing 2 shifts on R0 register with rotate left without carry, we obtain the result as this one. So now let us see what is rotate left with carry. So until now we have seen rotate left without carry. Now we are going to see rotate left with carry. So in rotate left with carry, we use the notation rotate LC, means rotate left with carry. So let us take an example. Rotate LC hash to R1. So this means we are shifting 2 bits in a register R0 towards left side by using rotate left with carry. So now let us take an example here. So the data in the R1 is this one. So this is the data before performing first shift. So after performing first shift, the leftmost bit. So this is the leftmost bit in the R1. So this is shifted here, and all the data is transferred to the left side. So after transferring, we get 1 0 0 0 1, so on 0 1 0, and here a vacancy is created, and this vacancy is filled by this carry. As here we have taken, by default the carry is 0, so the carry which is eliminated will be replace this vacant position. Now let us see the second shift. So after performing second shift, we are moving this leftmost bit to the carry, and the element previous one will be moved out from the carry. So, and vacancy is obtained at the rightmost bit. So now that vacancy is filled with this bit. So that vacancy is filled by this carry which is eliminated. So this is what meant by rotate left with carry. So until now we have seen rotate left without carry and rotate left with carry. Now we will see rotate right. So rotate right without carry. So similar to rotate left with carry, here we are performing rotate operation without carry towards the right. So here we are taking two registers R1 and R2, where R2 is equal to 2. That means here we are performing two shift operations towards right by using rotate right without carry. So this is the data in the R1 register, R2 register. So before first shift, this one. So after performing first shift, what will happen? The rightmost bit, that is this one, will be transferred towards right side, and the carry which is present will be eliminated outside. So this is rotate without carry. The vacancy which is created at the leftmost side is replaced by the bit which we have removed earlier. So the second shift, in this what happens? So in this the rightmost bit, that is this one, will be sent to the carry, and the previous one will be eliminated. Now this vacancy created is filled by this one, that is this one fills the vacancy. This happens. So in place of rotate R1 comma R2, we can also take #2 comma R1. So both are same. So now let us see what are rotate right with carry. So in this the notation is rotate RC. So it means rotate right with carry. Example is rotate RC #3 R2. So in this the data in the R2 register is 111, so on 0011, and by default we are taking 1 is present in the carry. So we are performing rotate right. The rightmost bit will be eliminated. So the rightmost bit is shifted towards carry, and the previous bit which is present will be shifted outside. So as we have performed the rotate right shift, a vacancy is created here. So this vacancy is replaced by the previously presented carry, that is this one, that is here this one is eliminated. So this one is used in filling the vacancy. And after performing second shift, here this one is eliminated from the carry, and we are shifting this one into the carry. So the eliminated carry, that is 1, is filling the vacancy that is created again. Here also a vacancy is created, and this vacancy is filled by this one. So now let us perform rotate right operation. So now here this one is eliminated, and this 0 is transferred towards the carry. And as we are shifted this data towards right side, a vacancy is created, and this vacancy is filled by the previous carry. That is, here the previous carry is 1. So this one fills the vacant position. So this is what the rotate instructions are. So thank you.